Periodically, you ask me to talk about specific AI-related topics. Today's presentation is about MCP. Let's dive in.
What is MCP and its role in AI? At its core, the Model Context Protocol, MCP, acts as a standardized pipe for your data, serving as a universal translator, or USB-C port, that connects AI models to external tools, databases, and environments. Instead of writing fragile custom glue code for every single database or API, the classic N by M integration problem, MCP establishes a unified structured connection standard, an N plus M solution, where models and external systems speak the exact same language. Here is how MCP operates as a data pipe, detailing its architecture, the data that flows through it, and a practical walkthrough of the data flow. 1. The structure of the pipe, client-server architecture. MCP split connects the AI environment using a clear client-server architecture. The client, the consumer. This is the AI application, agent, or IDE, like Claude Desktop or VS Code, that needs data or needs to take an action. It controls the LLM interactions. The server, the provider. This is a lightweight decoupled program sitting directly next to a data source, like a database, file system, or GitHub. It manages the local logic, credentials, and API tokens. The host, the surrounding application framework that coordinates the client. 2. The physical transport, how data moves. The data flowing through this pipe is strictly formatted using the JSONRPC 2.0 standard. The protocol natively supports two transport mechanisms, standard input/output, STDIO, used for local processes running directly on the user's machine. It is highly lightweight, fast, isolated, and requires no HTTP overhead. Streamable HTTP, used for remote cloud-hosted servers, such as enterprise data sources or external tools. It supports multi-tenancy and secure standard authentication like OAuth 2.1. 3. The primitives, what the pipe carries. To ensure models can consume information seamlessly, the pipe carries data packaged as three primary standard primitives. Resources, read-only data, data files, database schemas, text documents, or state information that the client can retrieve on demand. Tools, executable actions, functions. The model can invoke to perform a change, for example, sending an email, querying a database, or modifying local code files. Prompts, predefined templates. Suggested prompts and instructions built by server developers who know the underlying data best, helping the model format its responses. Context, external state markers such as progress updates for long-running asynchronous processes, allowing servers to talk back to the client. 4. Step-by-step, a round trip through the pipe. To understand how the data actually traverses the pipe, let's trace an AI agent checking database records. 1. Dynamic discovery. When the client first connects to the server, they negotiate capabilities. The server advertises its available tools, resources, and prompts by returning a machine-readable JSON manifest. The model dynamically sees what is available without hard-coded endpoints. 2. Model reasoning. The model processes a user goal, for example, find transactions for user Dan, and identifies the matching tool, for example, query_database, and arguments from the server's menu. 3. Sending the request. The client formats this tool call into a structured JSON RPC request and sends it down the pipe. 4. Secure execution. The MCP server receives the standard request. Crucially, the model never touches raw APIs or credentials directly. The server acts as a translator. It takes the structured parameters, translates them into the downstream service's native format, such as SQL or a REST API request, and fetches the raw data. 5. Returning clean context. The server formats the raw result into a clean, structured JSON response and sends it back up the pipe. The client hands this text to the model, which synthesizes it into a final answer for the user. By separating cognitive reasoning, The model, from programmatic data plumbing, the server, MCP ensures that data flows predictably and securely through a single standard interface, making any compliant model instantly compatible with any database or application.
Thank you for being a part of today's topic on MCP.